Now the next one, find magnitude of vector x if for a unit vector A vector it is given that A vector is unit vector, x minus A vector dot x plus A vector is 15. Now we have to find the value of magnitude of x. So x dot x, or we can say that modulus of x square minus A square is 15. Or you can simplify it as this also. Now A vector is unit vector, so this is value 1. Modulus of x square, 15 plus 1 is 16. So modulus of x has value 4. Now next one, find magnitude of vector A and magnitude of vector B if A vector minus B vector dot A vector plus B vector is 27 and magnitude of vector A is 2 times magnitude of vector B. Now A plus B and A minus B, so that is equals to modulus of A square minus modulus of B square. We have given that modulus of A is equals to 2 times modulus of vector B. Put this value here. 2 square is 4, modulus of B square minus modulus of B square. 4 minus 1, 3. 3 modulus of B square . 27 modulus of B square is equals to 9. So modulus of B has value 3. We want to find modulus of B as well as modulus of A. Given that modulus of A is 2 times modulus of B. So 2 into 3, that is 6. Modulus of B is 3 and modulus of A has value 6. Now next one, if A vector is equals to 5i minus j minus 3k, B vector is equals to I plus 3j minus 5k, show that vectors A plus B and A minus B are perpendicular. We have to show that these two vectors are perpendicular if their dot product is 0. We know that two vectors are perpendicular if their dot product is 0. So first we have to find the value of A plus B vector and A minus B vector. What is the value of A plus B vector? 5 plus 1 plus 3 minus 1 minus 5 minus 3. A vector minus B vector, 5 minus 1 minus 1 minus 3 minus 3 plus 5. Now take the dot product. A vector plus B vector dot A vector minus B vector. 6i plus 2j minus 8k dot 4i minus 4j plus 2k. We know that dot product of the same components has value 1 and the dot product of one component with any other component has value 0. So I dot I, 6 into 4, 24, 2 into minus 4, minus 8 into 2. 16 and 8, 24, their dot product is 0. Therefore, vector A vector plus B vector is perpendicular to A vector minus B vector. Now next one is, if two vectors A and B are such that modulus of A is 3, modulus of B is 2, A dot B has value 6, find magnitude of A plus B vector and magnitude of A minus B vector. Now magnitude of A plus B, squaring it, we know this value because we have given the values of modulus A, modulus B and 2 and A dot B. Therefore we will use this formula. Modulus of A is 3, 3 square, B 2 square, 2 into 6, 12. 13 plus 12. Therefore, modulus of A plus B has value 5. Similarly, we know the formula for modulus of A minus B square, modulus of A square plus modulus of B square minus 2A dot B. Modulus of A square, 3 square plus 2 square, 2 into 6, 13 minus 12, that is 1. Therefore, modulus of A minus B has value 1. Now next one, two vectors A vector and B vector. Prove that the vectors modulus of A B vector plus modulus of B A vector is orthogonal to modulus of B vector minus modulus of B A vector. We have to prove that these two vectors are orthogonal. Orthogonal means perpendicular. Let this vector as alpha and this vector as beta. Then we have to show that their dot product is equals to 0. Now take the dot product of these two vectors. A vector modulus B vector dot modulus of A B vector minus modulus of B A vector. Modulus of A square B vector dot B vector minus modulus of A modulus of B B vector dot A vector plus modulus of B modulus of A dot B minus modulus of B square A dot A. Now we know that B dot A is equals to A dot B. And this is the sign with plus sign and this is with negative sign, so it will get cancelled. Now we are left with modulus of A square. B dot B is modulus of B square minus modulus of B square. A dot A is modulus of A square. In multiplication, चाहे A term आगे है या B term, it doesn't matter. Therefore, it will get cancelled and the answer is 0. Therefore, vectors alpha and beta are orthogonal, or alpha vector is perpendicular to beta vector. Or we can say that alpha vector and beta vector are orthogonal. If A vector plus B vector plus C vector is equals to 0 vector, modulus of A is 3, modulus of B is 5, modulus of C is 7. Find the angle between A and B. Now we have to find the angle. Now first we can write it as this. A plus B plus C vector is equals to 0 vector. So we will write as this. If we want to find the angle, then we have to take the dot product, or we can say that squaring both sides. Minus C vector dot minus C vector. Now A vector plus B vector dot this, that is equals to modulus of A plus modulus of B square. Modulus of minus C vector square is plus C vector square. Modulus is positive. Now we have formula for this. Plus 2A dot B modulus of c square. Now we have given the values of modulus of all these: 3 square, 5 square, 2a dot b, c is 7 square, 49. So 2a dot b is 49 minus 34. So a dot b has value is equals to, now we will use the formula here. A dot b is modulus of a modulus of b cos theta, because we want to find the value of angle. Now modulus of a has value 3, b has value 5. So cos theta has value 1 by 2. 1 by 2 is the value of cos 60 degree. Therefore the value of theta is pi by 3. Now the next one. If a cap and b cap are unit vectors inclined at an angle theta, then prove that sin theta by 2 half magnitude of unit vector a minus unit vector b. Now we know that x vector dot x vector is modulus of x square. Here we want this. So a cap minus b cap whole square is a cap minus b cap dot a cap minus b cap. Now solve the dot product. A cap dot b cap, a cap dot a minus a cap dot b, b dot a minus b cap dot b cap. Magnitude of a cap square 2 times this minus magnitude of b cap square. Now a and b. Now for this a dot b we will use the formula modulus of a cap square. A dot b is equals to magnitude of a magnitude of b cos theta. Because we want to prove this, here angle is included, therefore instead of a dot b unit vectors we write this formula. Now we want to prove that sin theta by 2 is equals to this. This is a unit vector, so magnitude of this is also a unit vector. Here we have plus sign, 1 plus 1 2. Taking 2 common, here we have left with 1 minus cos theta. What is the value of 1 minus cos theta? Cos 2 theta is equals to 1 minus 2 sin square theta. If here angle is cos theta, then it is 1 minus 2 sin square theta by 2. 1 minus cos theta is 2 sin square theta by 2. So put this value here, 2 sin square theta by 2. That is 4 sin square theta by 2. A cap minus b cap square. इधर से हम square हटाएंगे, taking square root, then it becomes 2 sin theta by 2. Or we want to prove that sin theta by 2 is equals to, when 2 goes on left hand side, 1 by 2 magnitude of a cap minus b cap. This is what we want to prove. Note it down. Now the next one. For any two vectors a vector and b vector, prove that magnitude of a plus b is less than magnitude of a plus magnitude of b. Now we know that magnitude of a plus b square is equals to modulus of a square plus modulus of b square plus 2a dot b. Instead of a dot b, use the formula of dot product. that is equals to magnitude of A, magnitude of B, cos of theta. We know that value of cos theta is either equal to 1 or less than 1 for all angles. If this is less than 1, it means modulus of A square plus B square plus 2 modulus of AB cos theta. Instead of cos theta, if we put this value as less than equals to 1, modulus of A square plus B square plus 2 modulus of A modulus of B. It implies A plus B whole square is less than equals to, we can write it as modulus of A plus B whole square. A plus B whole square, A square plus B square plus 2AB, or modulus of A plus B is less than equals to modulus of A plus modulus of B. Now next one is, for any two vectors A vector and B vector, prove that A dot B square less than is equals to modulus of A square modulus of B square, and hence show that A1 B1 plus A2 B2 plus A3 B3 square is less than is equals to A1 square plus A2 square plus A3 square, B1 square plus B2 square plus B3 square. Now we know that A dot B is modulus of A, modulus of B, cos of theta. If we squaring both sides, A dot B square, modulus of A square, modulus of B square, cos square theta. Again we know that cos theta has value less than is equals to 1, so it becomes A dot B whole square less than is equals to modulus of A square modulus of B square. यहाँ तक तो हमारा प्रूफ हो गया. Hence we want to prove this. Let A vector as A1 I cap plus A2 J cap plus A3 K cap. B vector as B1 I plus B2 J cap plus B3 K cap. Now you can take the dot product. Dot product of A vector dot B vector is A1 B1 plus A2 B2 plus A3 B3 square. Modulus of A. What is the value of modulus of A? Is square root of A1 square plus A2 square plus A3 square. But here we have square. Therefore it has value A1 square, A2 square plus A3 square. Similarly, value of magnitude of B square is B1 square plus B2 square plus B3 square. When we square this value, square root will get cancelled. So this is the result. Now the next one. If A and B vector are two vectors such that modulus of A plus B vector is equals to magnitude of A vector, then prove that 2A vector plus B vector is perpendicular to B vector. 2A vector plus B vector is perpendicular to B vector. Modulus of A plus B, or we can say that magnitude of A plus B vector is equals to magnitude of A vector. Now squaring both sides, A plus B square is magnitude of A square plus magnitude of B square plus 2A dot B. Magnitude of A square will get cancelled. So 2A vector dot B vector plus B square is equals to 0. Now we want to to prove that these two vectors are perpendicular, then we will have to show dot product of these vectors is 0. 2 a vector dot b vector plus b vector dot b vector 2a dot b plus magnitude of b square. And here we have proved that this term has value 0. Therefore, 2a vector plus b vector is perpendicular to b vector. Now next one, if a vector makes equal angles with I cap, j cap and k cap and has magnitude 3, then prove that the angle between a vector and each of I, j and k cap is cos inverse 1 by square root of 3. We know that let a vector makes an angle alpha, beta, gamma with I, j and k, then cos square alpha, cos beta, cos gamma. Therefore, we know L square plus M square plus N square has value is equals to 1. Cos square alpha plus cos square beta plus cos square gamma has value equals to 1. Here we have given that it makes an equal angle, therefore alpha is equals to beta is equals to gamma.